Hi everyone. Let's take a look at the following example. Describe the transformation from f of x equal to x squared to g of x equal to negative 2 of f of 3 times x minus 4, close the brackets, minus 1, and graph g of x. So step 1, let's write down the transformation in order. And when I say write this in order, I mean exactly in the following sequence. In general, when you write down the words, the first step should be anything that you can reflect. So I would say step 1, reflect it. Step 2, stretch it. And step 3, move it. And the key really is step number 3. Do not talk about or do not write down the horizontal translation or vertical translation until it's at the end, right? So leave the step move it as number 3. So again, if we go back to step 1, let's talk about the reflection. So notice there's a negative sign in front of 2. That negative sign means reflected with respect to the x-axis. And again, depending on the textbook, depending on the teacher, depending on the course, sometimes they'll say reflection over the x-axis or reflected with respect to the x-axis. It's the same meaning, basically. Now, the next transformation is going to be 2, which is going to be what we call stretch it. And of course, when we say stretch it, it could also be a compression. So it includes both vertical or horizontal, whether you're stretching it or compressing it. And in this case, the 2 is in front of f. So that's going to be a vertical stretch by a factor of 2. Next, there's a 3 inside the brackets. So you have to think reciprocal. You got to think horizontal. So you can write down horizontal compression by a factor of 1 over 3. Don't forget, there's also the x minus 4 inside the brackets. When it comes to left and right, think opposite. So x minus 4 really means horizontal translation 4 units right. Last but not least, if you think about the minus 1 at the end, that really means vertical translation 1 unit down. So again, so far we took step 1, which was writing down the transformation in the appropriate order. Now, step 2 is going to be the mapping rule. So again, I would say in general, if you want to graph any function to a new function, use the mapping rule. This is probably the most effective way of graphing a new function. Now, again, if you think about that negative sign, that means reflected with respect to the x-axis, which means there's a negative sign in front of y. If you move on to the vertical stretch by a factor of 2, you're multiplying all the y values by 2. So now it becomes negative 2 times y. Next, there's a horizontal compression by a factor of 1 over 3. So this means you're going to take the x value divided by 3. Or you can say 1 over 3 times x. It's really up to you. Last but not least, if you're going to go right by 4, horizontal translation 4 units right, you can add 4 for the x component. And for a vertical translation, 1 unit down, you're going to subtract 1. So again, step 2, we're going to write down the mapping rule. Now be mindful, the parent function, the base function, is going to be y equal to x squared. So you go back to the basic function. You can think of the 5 basic points, something that you've learned back in grade 10 math. So for example, 0, 0, 1, 1, 2, and 4. On the other side, it will be negative 1 and 1, negative 2 and 4. This is where you can do a little bit of mental math, or if you prefer using a calculator, that's okay as well. You plug in negative 2. So that's going to be negative 2 divided by 3 plus 4. So that's going to be 12 minus 2. That's going to be 10 divided by 3. Next, you plug in negative 1. That's going to be 12 minus 1, 11 over 3. Then you have 0 plus 4, which is 4. 1 over 3 plus 4, that's going to be 13 over 3. And of course, if you plug in 2, that's going to be 14 over 3. Now, likewise, you look at the y components. You're going to plug in y to be 4. Negative 2 times 4 minus 1 is going to be negative 9. Next, you plug in y to be 1. That's going to be negative 3. Next, you're going to plug in y to be 0, and that's going to be negative 1. Next, you plug in 1. That's going to be negative 3. Last but not least, if you plug in 4, that's going to be negative 2 times 4 minus 1, negative 9. Now, once you write down the mapping rule, the difficult part, it's now over because you can sketch both the basic function and the new function. So again, I'm looking at some of these points, and the scale is going to look, roughly speaking, something like this. Again, I'm kind of imagining both cases in my mind before I'm sketching it. Okay, so let's see what happens. Now, in one color, I'm starting with the most basic function, which we can call the base function y equal to x squared, or f of x equals to x squared. And again, I'm grabbing these basic 5 points, which look something like that. Now, in the other color that we were using, let me just make sure I some color. There we go. I can grab the new 5 points. So I go right by 10 over 3, which is roughly 3. And I realize I should add a couple more units here. One moment. Let's go all the way to 5, 3, 4, and 5. There we go. Back to the same color. 10 over 3 is going to be 3.3-ish. Then we're going to go all the way to negative 9. The next point is going to be negative 11 over 3, which will be, roughly speaking, somewhere here, down by 3. Then we go all the way to 4, down by 1. Again, we go all the way to 13 over 3, which is going to be, roughly speaking, somewhere here, down by 3. Last but not least, you're going to go all the way to 14 over 3, down by 9, which is going to be there. Now, again, notice what I'm going to do. You really want to label these points. It's always a good habit to label the points because, as you can see, the graph I'm giving you, it's not perfectly accurate. It's a rough sketch. And if you label the points, you're trying to signal to your teacher or whoever is looking at this that these are the points that you're thinking about. And now you can connect them. You can also go back and label this. Now, what is the new function, by the way? If you think about g of x, again, the original function is f of x equal to x squared. When you plug this in, this is going to be, let's see, negative 2 times, open bracket. So you're going to plug in x squared in this case. Let's try one more time. I need a bit more space. So again, let's go back. Maybe I'll put it right here. So the function here, let's go back to here. G of x equals to, again, there's a vertical stretch by a factor of 2. There's also that reflection with respect to the x-axis. Then you plug in, again, to 3x minus 4, close the bracket square, minus 1. So that's kind of how you can express it in factor form. Now, if you like, I'll give you this other perspective. You can expand this. So if you think about 3 squared, that's 9. 9 times negative 2 is negative 18 times x minus 4, quantity square minus 1. And in case of thinking, like, how do I know this is right? Well, first of all, the maximum is supposed to be at 4, negative 1, which is exactly what we have in the graph. If you think about the step pattern, you're going to go right by 1, down by 18 this time. And as you can tell, if you go right by 5, you are going to go down all the way by 18 units. So that's a fast way to kind of double check that this is making sense. So again, that's how you graph g of x. If you find this math video meaningful and it's adding value to your life, consider to comment, like, share, and subscribe. I hope this makes sense.